right here. So it will be for customer name, product name, and quantity. And then I will click on OK. So now we have the accessors. So now if I restart my application, I can also leave this breakpoint. I will restart the application and then I will go back to Postman and send again the request. So here I will click on send, and now let's evaluate this order. So we see that the customer name is Alibu iPhone, and we have also the quantity. If I resume the program and go back to Postman, we see that we have the object that we already sent. So now I guess you understand the importance of having accessors while you use object to transfer data from a client or a REST client, which is in our case Postman, or it can be any other application like a front-end framework like Angular or React or even native JavaScript, and you need accessors to serialize and deserialize the object. So now as a next step, let's see how, for example, I can customize the name of this JSON field. So for example, I want to have a different name for my JSON representation and another different name in my Java object. Now to specify a different property name, and this case can happen, for example, in case I want to consume or I want to send data to a third-party API and the names are not the same as my Java object. For example, we can have a case of a customer name. It might be C name, P name for product name, and
4.0 release came out in March 2004. So this is a long time ago. This is quite a mature. Now let's take a look at a little bit of the detail in Spring, see how Spring does its job. We have to define a couple of terms like what is a Spring bean and what does the term metadata mean. And then also we can give a very brief summary of how Spring Boot fits into the picture. After we finish that, then in our next section, we can get right into the code. So let's start with Spring. The idea behind Spring is that it does what they call lifecycle management of these Java classes known as Spring Beans. Now, there is no actual definition of the term bean here. It's a reference to the Java bean term that came from the Java world much earlier. But a Java bean's just a plain old Java object. Now, there was a spec for Java beans, and it had a lot of parts in it that people no longer cared about outside of its immediate application. So eventually, when people wanted to use the term Java bean, they ran into the problem of saying, well, they're Java beans, but without this other stuff we don't care about. And they eventually went, look, look, let's just call them POJOs, plain old Java objects. Spring deals with these POJOs and it manages their life cycle. That means it instantiates them on demand. It provides them through this process we'll call dependency injection, and it gets rid of them when they're no longer needed. So Spring instantiates these POJOs that it will call beans and make it available for injection. Frankly, what we'll say is any Java class that Spring is currently managing is referred to as a Spring bean, if you will. Now, Spring also has a very large library of its own. It's got transaction managers. It has something we're going to see a lot of later, clients for RESTful web services, both synchronous and asynchronous. It includes database connection pools, and everything can be tested. We're going to see that. Another thing you're going to find with Spring is they make extensive use of existing open source projects. A problem that Spring Boot dealt with that we'll talk about shortly that Spring had is that Spring would use dozens and dozens of open source libraries, and it was always a challenge to know which version of each worked successfully with all the others. Spring Boot solved that, or at least addressed that problem, and we're going to see it. So we're going to see that your application will have 40 to 50 different jar files included in it, but it won't be that complicated from our point of view, as we'll see. Now, in order to do declarative services, in order to get what we want by asking for it, as opposed to writing the code, we have to communicate with the Spring container, using the terms from the previous section. This is done via something known as metadata. Now, metadata is, of course, data about the data. It's telling Spring what we want, but not how to do it. Now, in the original version of Spring, this was all done through XML files. And hard as it may be to believe, there was a time when XML was popular. It seems unlikely, but yeah, it did happen for a while. And the XML files are still supported. That still works. We're just not going to deal with that anymore. We may glance at one, but that's not really common practice anymore, but the legacy apps still work. Instead, Spring started relying heavily on Java's annotation support, the little @ signs with the name of a class after it. Java annotations are pre- and post-processors, some of which work at compile time, some of which work at runtime, and Spring loves its annotations, and they use them all over the place. We'll see tons of them. Now, later in version 3, Spring introduced the idea of a Java class that you never instantiated or called the methods in. Instead, it was a config file. It's a configuration file just in the form of a class. So the methods told the container what beans you wanted configured and how to set them up, and then Spring would read that and add them to its own application context. This is called a Java config approach, and we'll see a couple of examples of that as well. All of these mechanisms are still supported, but we're mostly going to use annotations and a little bit of Java config as well. Now, I use that term application context, and if you're in the Java world for any length of time, you know that the word context often references something global or effectively global. And Spring has a term called the application context that has many meanings. It's an overloaded word, if you will. One definition of it is that the application context consists of the current collection of beans that Spring is managing. When we say it's managing, we mean it instantiated them, it's handling the life cycle, it's providing them on demand through this process we call dependency injection. This is also sometimes referred to as the lightweight Spring container, which is only lightweight when you consider full-scale Java EE application servers to be heavyweight. So that's the term lightweight, and you'll hear that come up as well. In addition, there is an interface in Spring called application context, and there's about half a dozen or more implementation classes. In earlier versions of Spring, certainly before Spring Boot came along, we used to have to deal with that directly. That's how we got the application started. That's how we configured various beans. Now, Spring Boot hides a lot of that under the hood, which means we're going to need to take a look at it, see what it's doing. Application context has methods like get bean definition count, how many beans were defined, how many names are there, or getting individual beans. We'll see some of that later. Now, let's talk for a moment about Spring Boot as well, so that then we can dive into our code. Now, the purpose of Spring Boot is to make it easier to create a new Spring app and to auto-configure it. See, Spring apps were getting bigger and bigger and bigger, and a lot of people were creating new Spring apps by copying their old Spring app and pasting it and then modifying it. And that's an awkward way to operate because you can wind up with inconsistencies and problems and so on. Copy and paste is not a great reuse mechanism. So Spring Boot was created specifically to address two problems. One is, how do we create a new Spring app? And Spring Boot apps are Spring apps. We'll refer to the app as a Spring app, but we'll also have an additional API to look at provided by Spring Boot. It also does this auto configuration part. Now, we'll get to that in a moment. The creation mechanism was enormously streamlined by adopting one of the popular build tools in the industry. Now, the two major open source build tools in the industry when Spring Boot were released were Gradle and Maven. Older tools like Ant are still around, and there's newer ones around as well. Spring really wants you to use, or rather I should say Spring Boot wants you to use Gradle or Maven. And that will not only help you configure the project and build it, but it will also manage all those jar files, all the transitive dependencies as we go. Now, the auto configuration streamlined what you had to do in order to make a new Spring app. You see, with Spring Boot, you could just say, hey, Spring, all I want is a web app to build a RESTful web service. And oh, you know what? I would like some persistence as well, using the Java Persistence API, JPA as we say. And maybe we should throw in Spring Security. You'd put in these starters. And starters are basically shorthand that they refer to dozens sometimes of individual libraries. Now, the auto configuration says, hey, you know, I'm going to make a RESTful web service. And in my web service, when I return an object, I want you to serialize it into JavaScript object notation, JSON form. Before Spring Boot came along, you'd have to declare some kind of JSON parser bean and pick which one it was and tell Spring how to configure it and all of that. And everything was configured that way. So you get these configuration files that were enormous. They had lots and lots of beans in them. This is why copy and paste reuse was so popular. Well, what happens now with Spring Boot is when you ask for the web starter, you get the JSON starter automatically. The JSON starter includes the Jackson JSON parser as an open source library. And just the fact that it's on the class path is enough for Spring to go, oh, you're returning this class? I'll serialize it into JSON, and I'll use that parser because it's on the class path. Or creating a data source, a database connection pool. In Spring, that was a multi-step process involving several different beans, including things like some weird thing called a vendor adapter, and so on. Now, all we have to do is put the JDBC driver on the class path, and we have a standard configuration file where we could put in like the username and password and the URL and everything happens automatically. And this is all because of Spring Boot. If they had it to do over, I have no doubt that there would be no distinction between Spring and Spring Boot. It would be all one project. The only reason it's still separate as a project is simply history, that it just came up that way and they've maintained it that way. But nothing is done in one project without knowing about what's going on in the other. They version within a week of each other. Everything is coordinated. So there's separate projects with separate documentation, but nobody these days would make a Spring project without going through Spring Boot to do it. Now, to get started, what we need is a website known as the Spring Initializer, and we're going to look at that. That's the site for creating new Spring apps. It's at start.spring.io. It's right off the Spring homepage. Now, we will look at it, but the truth is it's already incorporated in all the major development environments. It's in IntelliJ Ultimate. It's linked in Spring Tools, which either has an Eclipse plugin or a VS Code plugin. It's basically the site that helps you create your app, except that the IDEs are then front ends on that site, so you don't have to actually go there. We'll go there anyway and take a look at it, but then we'll switch to an IDE and go from there. Once you have configured your initial app, Spring will generate a zip file for you, which you can then download, expand, and then load into whatever IDE you prefer, whichever development environment you want to use. The last thing I'm going to say here before we actually get started is that Spring Boot also decided to make it easy to get started with web apps without having to make your own server, without having to set up a server that you could deploy to over and over again, even something as straightforward as Tomcat. What Spring Boot does is it will make a single class in your app that has a standard Java main method, public static void main string array args. This will be in your app, and the beauty is you can just run that like any other Java application, either in the IDE or from the command line. And if this is a web app, if this is a RESTful web service, it will start up an embedded version of Tomcat. Believe it or not, and wind up building everything from there. So it makes it much, much easier in order to get started and to run and to develop. Of course, in combination with a build tool, Gradle or Maven, it will also generate an output jar that has Tomcat embedded in it, and that becomes your deployable artifact should that be the thing you need to deploy into a cloud provider or something of that nature. Now, in the next section, we're going to start building an app. And we're going to use Spring's so-called MVC, the Model View Controller framework that lets you build both web apps and what we really are going to care about, RESTful web services. So that's coming in the next section. Hope you make it to that one as well. Welcome back. Now it's time to actually create an application and get into the code. Hopefully that will help make a lot of these terms we've been talking about make a lot more sense when you see them in context. Now, the site I'm on right now is spring.io, the homepage for Spring. Everything you need will be linked from this site. We'll be looking at the projects a little bit later. We may look at the Learn section and more. One thing under projects at the bottom is Spring Initializer, this link right here. When I select that, it brings us to that page, start.spring.io, that I discussed in the last section. Now, this can be viewed as it shows here in day mode. It's a little bright that way. I like to go to the night mode, which seems to show up a little bit better. We make this a little bit bigger, magnify it a little bit, make it a little easier to read, and then we'll take a look. Now, you can see in the Spring Initializer, the first decision they ask you to make is which build tool you're planning to use, Gradle or Maven. And you can use the Groovy DSLing Gradle or the Kotlin DSLing Gradle, and either one is fine. In fact, you can use Gradle or Maven. They both do basically the same things. I'm primarily going to favor Gradle in this course because I like the test reports that come out of it a little bit better, and I think it's a little easier to read the build file than reading XML, but I'll do at least one application where we use Maven instead. Feel free to use whichever one your company happens to prefer. I'll stick with the default at the moment, which is Gradle with the Groovy DSL. You see here that Spring supports Java or Kotlin or Groovy for the initial app. We're going to use Java, but Spring has always been pretty friendly with these non-Java languages that compile to JVM bytecodes, and it has special capabilities for both. So keep an eye on those if it turns out they have something interesting that you might want. Now, here is the only major decision you have to make in your application, and that is which version of Spring Boot you're going to select. The beauty is you only have to pick this single version, and that will set default versions for everything else in your application. You can later override those versions if you want. In fact, pretty much everything in Spring is configurable, but we want to pick one right now. Now, the snapshot versions are changeable pretty much day to day, so I don't really want to use one of those. The M2 here is indicating a milestone version. Spring versions tend to go through about 5 or 6 milestone versions and then a couple of release candidates before they become general availability, the actual release version. The only release versions that are shown at the moment is 3.0.5, which is the current latest version of the 3 series, and 2.7.10, the latest version in the 2.x series. We're going to stick with the default again, which is 3. In this case, 0.5. Pretty much everything we do, though, should work on later versions of Spring Boot 3. Again, don't select Spring Boot 3 unless you know you have Java 17 available. That's required. Now, if I scroll down under project metadata, you choose a group and an artifact. Now, that would be significant if we were making a library for somebody else to consume. We're not really doing that, but you'll notice that a group and an artifact put together becomes the default package for our application. So it's easier just to modify the group and the artifact. And what I'm going to do here is I'm going to make this com.O'Reilly, and I'll leave the name of the artifact as demo. Now, the name in the artifact, again, that's the name of the application itself. Usually name and artifact are the same, and that's no loss of any generality there. This is, in fact, a demo project for Spring Boot, so our default package will be com.O'Reilly.demo. Now, I'll come back to the packaging in a moment. You can see at the bottom, the default version selected is 17. At the time this is recorded, that is the latest long-term support version of Java. If you are forced to use Java 11 or 8 or something less than 17, you have to go back to Spring Boot 2, but we're going to use 17. The current version of Java is 20. We could use it, but why? We'll just stick with 17 at this point. That's fine. Now, the packaging has shown how much the Java world has evolved over the last 20 years. Back when Spring was shiny and new, everybody built WAR files, web archives that were structured in a particular way to be a web app and were deployed inside a container like Tomcat. Now, it's much more common to build a jar file that has an embedded version of Tomcat inside it. This is due to the rise of the cloud, cloud deployments, as well as the rise of mobile. There's been a lot of changes over the last couple of decades, and now the default deployment is jar deployment, and we'll take a look at that. The only other thing we have to select are our dependencies. Now, when I click on the Add button here, you can see there's lots of options in here. This thing goes on and on and on and on. Here are the couple I want to deal with in this first application. Before I leave it, let me mention that Graal VM native support. This is one of the neat features of Spring Boot 3. The ability to create an application with an incredibly fast startup time and low memory requirement. We'll get to that later. Right now, we don't want to start off with that immediately. Tools like the dev tools, those are nice. If you already know Lombok annotations, those are fine. No. The one we're going to use is this one called Spring Web, which says build web, including RESTful applications using Spring MVC. It uses Apache Tomcat as the default embedded container. This will make a jar file that is your deployable artifact if you want to deploy this later to the cloud. So I definitely want that one. Now, if all I was building is a RESTful web service and I didn't care about persistence, we're going to do persistence. assistance in a later module, I would be done. But I want to build a web app and then build a RESTful web service. And in fact, we want to put both in the same application. The web app may not be as familiar to many of you, depending on your experience, although if you are a little bit older, you may recall plenty of web apps that generate the view layer on the server side and then present it to the user in a browser. Let's build one like that with one simple view, and then we'll go back and build a RESTful web service, and we'll stick with RESTful web services the rest of the way. Now, if we're going to have the view generated on the server side, I'm going to click the Add button here, and underneath the web category is template engines. And we have TimeLeaf, Apache FreeMarker, Mustache, and Groovy templates. The one I'm going to select is TimeLeaf, which says a modern server-side Java template engine. Again, the views are going to be compiled on the server side, and all that's going to be sent to the browser is HTML. That's not nearly as common these days as RESTful web services, where the view layer is built out of JavaScript frameworks like Vue or Backbone or React or Angular, any of those. We'll use TimeLeaf, which is basically just a set of tags that get embedded inside your HTML. But again, the client side, the browser's never going to see those tags. They're going to be compiled on the server side, and all that's going to be sent to the browser is straight HTML. So let's select that, and that's all I need. Now, what I can do is I can explore this. If I hit the Explore button, you'll see the structure of the app that's generated, and build.gradle's highlighted, and you can see the code in here. Now, we're going to look at that in the IDE, make it a little bit easier to see. But notice that, and inside here, inside the source folder, is your normal structure, source main Java, with our package and a class called demo application, and source test Java with the package and demo application tests, as well as a resources folder under source main that has an empty application.properties file and a couple of empty folders that we'll look at later. Now, if I was to close this and say, I want it in Maven instead, I just click on Maven. This time, if I explore, now I have a pom.xml with the equivalent information in it, including a Spring Boot Maven plugin. In this particular one, I'm going to want to do this inside my IDE. So what I could do now is click the Generate button and download demo.zip, and then unzip it and import it into the IDE. Instead of that, I'm going to end this section, and in the next section, we'll create the same application using IntelliJ Ultimate, which has Spring capabilities built right inside. So that's coming up in our next section. this time, I'm now looking at IntelliJ IDEA Ultimate Edition. The Ultimate Edition includes Spring capabilities as a plugin. The Community Edition, which is free, does not, but the Ultimate Edition is really, really nice. Now, the capabilities we're talking about are, well, many of them exist in some of the other IDEs, but I don't think anything matches the sheer power of IntelliJ Ultimate. For our purposes, I'm going to use it mostly in order to speed up the development process and show you the code with all the appropriate syntax highlighting and everything. So in IntelliJ IDEA, all I have to do is hit New Project and then make sure that what I have selected over on the left is the Spring Initializer. This is the plugin. As it says, create a Spring Boot application using the Spring Initializer service. And in fact, you could see up here, the server URL is start.spring.io, the actual website that we looked at before. In fact, this is just a front end on that, if you will. So I'm going to make an application called demo. This time, I'm going to put it under my a temporary directory that I'll keep available for our entire project. So let me put it under temp O'Reilly, and we'll call this Spring and Spring Boot course, something like that. And now I select my language. The default is Java, that's fine. Again, Gradle using the Groovy DSL is the default. You could choose the Kotlin one or the Maven one if you want. I'll change the group here to com.O'Reilly, and that changes the package name. And again, my Java version is Java 17. Later, we'll look at some other options for that. I'm compatible with Java 17. I'm using jar packaging. It's time to click Next. In the next screen, I see that under Spring Boot, it's showing the exact same versions we saw on the web page, because again, this is generated from that web page. I'm on 3.0.5. The dependencies I want are, well, one is under web here, it's Spring Web, and the other is under template engines, it's Timeleaf. So these are the exact same ones that we reviewed in the previous section. Notice that they're listed over here on the right. I'll now click the Create button this time, and IntelliJ will load this application into the IDE. The one plugin that I need to mention as we go along is I have a plugin in IntelliJ called Nyan Progress Bar. It replaces my progress bar with that little Nyan cat going back and forth, and I still find that amusing, so that's what I have. Here we have the project generated. It's highlighting right now the help file, help file written in Markdown, which shows you the code and some links to the Spring documentation as well as Spring Boot documentation and so on. We're not going to need that right now, but it's nice to know it's there. Again, my structure is source, main, Java, and here is the class called demo application. Here's source main resources, which has the static folder and the templates folder. As we're going to see shortly, that templates folder only exists because we added the Timeleaf dependency. We have an empty file called application.properties, which we'll fill in later a bit more. We have the source test Java, which has the package again and demo application test, which includes a single empty test inside it. And finally, I should note that there's a build.gradle file, which has all the same information we saw from before. We have the Gradle wrapper, that's the script here called Gradle W, and one for Windows called gradlew.bat. We have a settings.gradle file, which just sets the name of the root project, and that's it. If we had selected Maven instead, we'd have a Maven wrapper and a Maven wrapper for Windows, and we'd have a pom.xml. So either way. Now let's take a brief look at the build.gradle file. It starts with a list of plugins that have been added to this project for Gradle. These are Gradle plugins, not Spring plugins. We are doing our application in Java, so it uses the Java plugin. This is a plugin provided by the Spring people. It's a Spring Boot plugin, and there was our version number. We can now edit this file if we want to change the version number later. It also includes a plugin called Dependency Management, and the beauty of this one is you'll notice down here in the dependencies block that we have 3 starters, none of which are showing dependency versions on them. The reason they don't have versions is the dependency management plugin is working with the Spring Boot version and supplying default values for all of these. Basically, the same version as the Spring Boot version. Again, we can override that if we want. Our dependencies are going to be downloaded from Maven Central at the moment. You can replace that with your own internal Maven repository if you want. There's our group and our version, and our source compatibility is 17 because we chose Java 17. The last piece of the puzzle is down here at the bottom, where this informs Gradle that our tests are using JUnit 5, JUnit Jupyter, as they say, or here using the JUnit platform. Incidentally, you could fix the code assist on this by adding an argument to the named method called test, like that. And that will be enough to tell Gradle that this task that they're configuring is of type test, and therefore now it knows what the JUnit platform method is. We can synchronize our project, and now we are basically ready to go. In order to do a proof of concept to make sure everything was created properly, what you can do is go to demo application tests, which has that empty test, and let's go ahead and run it. So I will run all the tests in that project. There's only one. And what we will see is everything compiled and all the dependencies being downloaded if necessary. And in fact, it's already finished on mine. You see that context load passed. You see a whole bunch of debugging information printed. There's the Spring splash screen identifying we're on version 3.0.5 of Spring Boot. We see here that it actually said, oh, we started up the tests, and then it shut them down because we don't have anything to do. And it all happened, at least on my machine, very, very quickly, in a little over half a second. So that just demonstrated everything worked. Good enough. In the next section, the next video, we'll now add something to this to make it actually be an MVC application. We'll start by adding a controller. Then we'll add a view. and we'll add tests and go on from that point. So hope you enjoyed that. See you in the next video. Welcome back. In this section, we're going to add a basic controller for a web application. Later, we'll wind up adding a REST controller as they say to create a RESTful web service to this same project. But we have to start somewhere. So we'll start with the classic C out of MVC, Model View Controller. We'll start with a regular controller and then see how that's different from a RESTful controller later. In our current application, we have a root package called com.o'reilly.demo that contains only one class, demo application, which has our standard main method in it. What I want to do is I'm going to organize this by making a sub package called controllers and then adding my controller to that package. Now, it's very important for reasons we'll get into later. It's very important to make sure that we are a descendant package of the root. This com.o'reilly.demo is very important because that's where the annotation at Spring Boot application resides. And that's where our component scan will start. And I'll define all that later. So at the moment, let me make a new package called controllers. And inside that package, I'm going to make a Java class called hello controller. So again, the important fact here is that this is a package that's underneath com.o'reilly.demo. I could have put everything inside com.o'reilly.demo. If that's simpler for you, be my guest. But I'd like to organize this into a mechanism that you may in fact encounter in practice. There are many ways to divide up applications into packages, but this is one of them. Now, in order to make this a controller, I'm going to add an annotation here that is at controller. And you see that that is from the org.springframework.stereotype package. Now, when I look at the definition of a controller, the documentation says indicates that the annotated class is a controller, e.g. a web controller. And that's all it says about it. So that's a little vague. I mean, if you don't already know what controllers do, you're not really sure. But basically what controllers do is they receive HTTP requests, and then they either return an HTTP response or redirect you to a view somewhere. This one's going to redirect to a view. Our REST controller is just going to dump serialized objects into the output. One thing it does say, however, is this annotation serves as a specialization of at component, allowing for implementation classes to be auto-detected through class path scanning. Yeah, we're going to come back to that, but that's really important. So at any rate, now it's time to put in our method that'll do the actual work. Now I'm going to add a method to my controller. It's going to be a public method that returns a string. It's going to be called say hello, and it takes a string name as an argument. But rather than returning hello in the name, we're going to return a hard-coded string, which is just the word welcome. We're going to have to explain that. I'm going to have to talk about why we have that structure, and we'll get to that in a moment. Now, I need, first of all, to connect this to the outside world. What controllers do is they receive HTTP requests. So what I need to say is, hey, Spring, when we get an HTTP request to this application, if it's this particular URL, call the say hello method. I need a way of connecting a particular URL to this method. And in fact, that's an annotation called get mapping. Now, get mapping, and I will use the /hello URL for it. Get mapping is something called a request mapping with the method being get. This is what they call a composed annotation. It's a shortcut. Instead of writing request mapping method equals get or request method.get, we just say get mapping, and it's got request mapping method equals get on it. Now, what does that mean? That means that when the Spring app receives a GET request, an HTTP GET request, to /hello after the default URL, which is going to be localhost 8080, then it should invoke this method. Now, what about this name here? Well, right now, what I really want it to go to is localhost 8080 /hello, but I'd like to provide that name as an optional argument. When we get to our RESTful web services, we'll look at something called a path variable where we plug in a value as part of the overall URL. Here, what we're going to use is a query parameter like name equals Dolly. So we'll put in a question mark at the URL and then put in our name inside it. Now, again, I put this in a comment. That's what we're going to want in a browser. But just right now, I want to see how do we map to that. So we already have the hello part. In order to get this name, you notice that I'm using, or what I'm intending, is a query parameter with the same exact name as that. I want to use name again. So there's another annotation that goes on this parameter on the method, and we call that at request param. Now, if I leave it like this, everything will in fact work, at least as far as we've gone so far, but then name will be required. And I don't really want name to be required because it turns out that I have an obvious default. I want to just say hello world. I mean, this is a hello world application. And whenever you're starting a new framework or API, you always want to do a hello world app. So I want to say, hey, if they provide a name, use it. But if they don't, let's call it world. So I put in parentheses on request param, and one of the available parameters is default value equals, and I'll put in the string world. Now what that does is that basically says, if the user provides a name in a query string, take that. But if they don't provide anything, use the default value of world. And as the documentation says, the default value to use is a fallback when the request parameter is not provided or has an empty value. So isn't that convenient? Supplying a default value implicitly sets required to false. So you used to also have to say, yeah, this isn't required, but now simply by providing a default value, I've done that. Now, hopefully everything we've done so far is relatively intuitive, because now comes the part that's going to look weird. I now want to add a second argument to the say hello method. The first argument is name of type string. The second argument is going to be of type model from org.springframework.ui, and I'll just call it model again. Now, what the heck is going on here? Well, the documentation isn't very illuminating, so I'll just tell you, a model is basically a map, a collection of keys and values. And what it's going to do is that Spring will take the keys and values in this model, it will add it to the current request, current HTTP request, and then forward to some view destination. Now, how do we make it so that that model has our name in it? We simply say model.add attribute, and we'll put in user as a string here and the value of name. Now, this little highlight attribute name colon, that's not in the code. That's IntelliJ just giving me what's called a parameter hint to let me know what add attribute looks like in the Java docs. They see it actually as attribute name and then some object, which is the value. So what I've done is taken the supplied name and added it to the model under the key user. The string is user. So far, so good. I have one remaining issue here, and that is this welcome string. Now, in IntelliJ Ultimate, when I mouse over it, I'm getting a warning, and it says cannot resolve the MVC view welcome. You see, every problem in computer science, goes the cliche, is solved by adding a layer of indirection, something between me and where I want to go. There is a class in Spring called model and view, where I could say, here's the model and there's the view I want to go to. But instead, I could just return this string. And what Spring will then do is forward us to the source, main, resources, templates, welcome.html. Now, that's a mouthful, and we'll have to talk a little bit later about why. But the important part is we go under source main resources that's in the class path for a file that's not a Java class. There's a subdirectory called templates, which was added because we're using Timeleaf, and then it appends HTML at the end. This word welcome here is exactly that word welcome there. So that's everything in the controller. But of course, we don't have a file underneath source main resources templates called welcome in that directory. So in the next section, we're going to add that, and then we'll see all this whole thing work together. So this is the basics of our Hello World app, and in the next section, we'll discuss it in a bit more detail and add the view layer too. So see you there. Welcome back. We almost have a complete application. We just need a view now. Now, I want to contrast this with RESTful Web Services. With RESTful Web Services, we'll return an object. The object will be serialized into JSON data, and then we're good. But for a web app, we want a view, and a view, again, is going to be compiled on the server side, and then all that's going to be returned to the user is straight HTML. So we'll see that in this section. Now, before I put in the view, I want to point out one other interesting little feature here. This model argument is almost, but not quite, what we consider dependency injection in Spring. See, we declared a dependency. We put in an argument, and then Spring, quote, injected it. This model is, in fact, an interface, and yet we're calling add attribute on it inside the method. So it's got to actually be an object. There's a class somewhere that implements the model interface, and that class is instantiated and provided on demand. Now, we're going to distinguish this from dependency injection a little bit later when we talk about things like the auto-wired annotation and stuff like that. Also, you can't put any arbitrary class in the method here. There's only a handful of classes that are in fact supported, and they're listed in the Spring MVC documentation. But the important part is, remember, we're not calling this method. We're providing a URL, or we will when we run it. And then Spring is connecting this URL to this method, and then it sees, oh, you want a model also, and then provides the model on demand. We didn't have to look one up.
started with Linux, that a lot of people out there have not used Linux even one single moment. But you hear about it, it sounds really interesting, it makes you seem really cool if you use it, right? So people want to get that experience. And unfortunately, most of the training that's out there jumps in at a higher level, expects you to have a lot of previous knowledge. So we wanted to create a series that didn't require a lot of previous knowledge, that could let you hop in and start to learn about what the Linux operating system is, where it came from, and get a chance to see how you can use it, or even if you should use it, because it's not right for everybody, and you might need to know, can you determine that? Should I even bother looking into Linux? And this course is really designed to help with that. It's designed to be your first step in the direction of learning to use the Linux operating system as your primary OS.
Now, who would benefit most from watching this series?
This series is absolutely geared towards people with zero Linux knowledge, right? So if you've never even installed Linux, or maybe this overview is the very first time you've heard of the Linux operating system, then Linux for Beginners is going to be perfect for you, because we're going to walk you through the process of understanding how the OS works and how to use it.
I honestly think one of the worst possible things you can do when learning something new is that you go on the internet, find the perfect way to do it, and you just implement that. The reason being is that you've missed out on all of the learning, right? You're just a tutorial Andy again. You're just like, okay, so the actual perfect answers, you just go straight to this thing and, it's awesome, right? There we go. We just figured out exactly why it's good. But inevitably, you're going to take that good thing, you're going to use it wrong, you're going to run into a whole bunch of issues because you don't know why it's made that way. I highly recommend anytime you learn something new, build a proof of concept, build something small, write something like somewhere between 2 to 5 to 10,000 lines of code around some idea. It's gonna take you a few days, quite a few days to get through it, but you're gonna learn so much doing that. And then you understand why people do this. And then you can actually use this without shooting yourself in the foot. I honestly think one of the worst possible things you can do when learning something new
We all say it, that code is bad, this code. In a recent post on the tech media site TNW, they talked about 5 ways to boost your salary as a software developer. I think that one of them misses the point altogether, 2 are plain wrong, one of them's only part of an answer, and the last is rather short-sighted and they miss the most important point of all, as far as I can see. So let's discuss by thinking about whether that's the right way, that focusing. Learn a high-paying language. Learn to work alongside AI. Well, yes, if your goal is to make money, language choice makes some difference. But let's be clear about this. There's not one language that makes you a millionaire and another. We all say it. Either it doesn't do what it should, or even if it does do what it should, it's too hard to change it when we need to change it. I'd argue that that's it. Everything else is secondary to those 2 things. If it does what it's meant to and it's easy to change, then it's good code.
Hello, it's closer to social engineering. So I thinking about it. I think like really well that doesn't is going for just reading like documents, working in structured smaller groups because that's our work environment, right? We're usually working in lean, small, agile teams. So when it comes to like, larger settings, we like for a little people with and this sweet girl came up, could have allowed her as a first year people with no agenda at all. Your only agenda, you're not looking for specific people to talk to. Too many times, like people would like try to find a recruiter somewhere on so that I could get the main one. Conversations occur naturally in networking conversations, right? So you can be able to stories emerge. we're trying to brainstorm for like features. Your picture, you know? Okay, it's against each other. So have like your simplified, that's to myself, especially the moment I left Singapore, went to the States. Who the hell here at like subcon? It's descript, and they work very well in terms of like experiences that start from scratch. My experience in having had the ability to work on design systems, so I know how UX UI works. You know, like I see that as an expensive label. But always be some aspects of these labels that you have. But what are your limited and expensive? This is a real conversation that happens, simplified but real. So a convo might go. So I was talking when I first met my friend. She later I found out was wait, I'm actually a technical, especially so one to remember that not just you, the participant is also have, and that you can do to start meeting someone all the way to the end of time, all the way until you decide to look like is okay. Maybe you're talking, and at some point you're like, oh, can I have your contact? If you can identify like the person I've done and somebody I completely didn't know, I probably wouldn't talk to you if I use like a blah blah blah. Like, they don't want me. Then we stop there. But what about considering what's happening on the recruiter side? And that's what we're trying to achieve here. So this is the Instagram link to Women Dev.
And I remember one experience I would never. And when they're really small, what do they know, right? So they're sitting there and watching things. I keep coding. They slam on. So this is another lesson in architecture. This is the best way to demonstrate, right? The more moving parts you have, the more systems break, right? So this is just the philosophy we can learn from. There you go. Thank you. So excellent. Thank you so much. So that is one of the beautiful things, right? We can never have simple things because that's boring. And when we have complex, sorry?
All right.